Ankur Scientific Energy Technologies Private Limited, a company established in 1986, has been in the forefront of research and developmental activities in the area of non-conventional energy sources. Set up by Dr. B.C. Jain, an internationally acclaimed technocrat, the company, since its inception, has an enviable record of development in the area of biomass gasification. Today, Ankur is seen as the world leader in this technology area. Its indigenously developed technology is now being marketed to more than 25 countries worldwide, including developed country markets. Let us start with understanding the process of biomass gasification. Biomass gasification is basically conversion of solid fuels like wood, rice husk, peanut shells, and agricultural residues into a combustible gas mixture called producer gas. This is achieved through partial combustion of such biomass. The gasifier is essentially a chemical reactor where various physical and chemical processes take place. 4 distinct processes take place in a gasifier: drying of the fuel, its pyrolysis, combustion of the same, and finally its reduction. A typical gasifier plant based on the Ankur design will consist of a gas reactor, a gas cooling system, and a gas filtering system. Gasifier demands biomass of a certain moisture content, sized within a certain range. Many biomasses such as rice husk, peanut shells, etc. can be used as are, but many others like wood branches, EFB, and other agri residues like cotton, soybean, mustard stalks need to be sized and dried. A typical setup for an Ankur-based gasifier power plant is shown. Biomass sizing is not shown here. Thus the starting point here is the dryer. This equipment shown is a rotary dryer. Here biomass feed is brought into close contact with engine exhaust or hot air. This results in the reduction of moisture content of the biomass to less than the required 15 to 20%. A belt conveyor is used to feed the biomass from the dryer into a bin. From this bin, another belt is used to feed the biomass into a bucket elevator. The bucket elevator, which is also called a skip charger, transfers the wood pieces from ground level into the gasifier. The operation of all the conveyors and the skip charger is controlled through biomass level sensors installed inside the gasifier. The Ankur gasifier itself has the following equipments: a double feed door assembly. This is used to ensure that there is no airflow into the gasifier while the biomass is being fed into it. Nozzles, which control how much air enters the gasifier. A comb rotor placed at the bottom of the reactor, which removes charcoal and ash from the bottom of the gasifier. A water-cooled screw conveyor, which is used to cool and to convey hot ash and charcoal from the reactor to the point of disposal. The producer gas generated from the gasifier will contain small amounts of tars and particulates. These will need to be cleaned out from the gas, and the gas will need to be cooled before it can be used for running engines and generating power. The most widely used method for cooling and cleaning of producer gas is the wet gas cleaning method, in which gas is scrubbed with water. This recirculating water needs regular treatment for removal of soluble hydrocarbons and particulates from it. Ankur Scientific has recently developed a state-of-the-art dry gas cleaning system. The major advantages of this system are: there is no direct contact of gas with water, hence there is no process water generation. There is no foul smell, as neither a process water pond nor any evaporative cooling of process water is required. the sludge generation is much lesser, thus reducing sludge handling. Most particulates and tars are removed in dry form, making their handling much easier. Part of the specific heat in the gas can be recovered in the form of hot air or hot water. The dry system needs much lesser maintenance and also needs lesser manual intervention. The dry filtering system consists of a startup subsystem, a gas temperature control subsystem, an automated ultra-gas purification subsystem, a condensate removal subsystem, a condensate treatment system, fine filters, pleated filter, and a dry blower. The gasifier is started using the startup subsystem. The gas passes through this circuit till it reaches a temperature of about 450 degrees centigrade. Once that temperature is achieved, the gas is allowed to pass through the gas temperature control subsystem where the gas is cooled to about 250 degrees centigrade. Here ambient air is used for cooling the gas. This allows some heat recovery. The gas then passes through the automated ultra-gas purification subsystem where bag filters coated with a catalyst are used to remove tars and particulates. This unit comes with a reverse pulsing arrangement to allow periodic, automatic cleanup of the bags. The gas temperature control subsystem and the automated ultra-gas purification subsystem collect some ash and carbon particles. The condensate removal subsystem consists of two heat exchangers. The first heat exchanger cools the gas using ambient temperature water coming from a cooling tower. The second heat exchanger uses chilled water to finally bring the gas to a temperature of around 25 to 30 degrees centigrade. In this process, light tars and some particulates are condensed out. A condensate neutralization system is also provided as part of the package. There is then a mist eliminator which removes condensed water particles from the gas, sawdust filters which are used to further clean the gas. Parallel line of filters are offered for continuous operation. And finally, a fabric filter which serves as the final check before the gas gets to the use point. The gas now has tars and particulates below 5 ppm. This clean gas can be injected into turbocharged and aftercooled engines to generate electricity. The electricity generated can be fed into the grid or can be used for captive power. The entire system can be automated to a very high degree. A PLC-based control panel is provided as a standard with the system. Various temperature, pressure, and level sensors are used to control the reaction and give alarms or remotely shut down the system. Ankur Scientific offers systems which can consume from 10 to 2000 kgs of biomass per hour. Based on the output needed, multiple gasifiers can be connected in parallel. Ankur Scientific has done projects from the 10 to the 10,000 kilowatt output levels. Ankur Scientific welcomes you to join the clean energy revolution. Thank you for your time.